Have you ever wondered where the edge of the universe is? Where that line is beyond which the universe no longer exists? And what that area might look like? Does this boundary even exist at all? After all, we know that the expansion of the universe has not stopped since its inception. Hubble subscribe. Now we have a simple truth. Everything has a beginning and an end. We can say that this applies to the universe as well. That sounds quite logical. However, we should keep in mind that we can't see the entire universe. Everything is limited by the speed of light. That's why we observe only the part of space whose light has reflected and reached Earth over the billions of years of the universe's existence. We call this area the observable universe, or the metagalaxy. We mean that in this part of the universe, there are opportunities for astronomical research. The most distant objects we can observe are located 45 billion light years away from us. The observable universe contains about 200 billion galaxies of various types. So it turns out that, relative to us, the inhabitants of Earth, the universe has boundaries. It also takes on a more or less clear spherical shape. However, in reality, the universe is much larger. What does it look like beyond the visible part? We need to determine how large space is and if it has an edge. If there is no edge, then how does the universe function? We run into problems with all these versions. Let's imagine that the universe really does have boundaries. Then it means that there must be something beyond the edge of the universe. However, this contradicts the statement that the universe is everything that exists in our world. That's its essence and foundation. At the same time, we can consider the possibility that the space of the universe is still limited, but there are no actual boundaries as such. There are still a lot of questions left. What do we even mean by these words? Let me give you an example. Imagine you're going on a trip around the world. Let's say you decide to travel only eastward. So you travel for miles, hundreds of thousands of miles, and eventually you return to the point where you started your journey. You left it heading east, but you returned from the west side. This is a vivid illustration of what we call a finite space without boundaries. As you can see, the Earth is not infinite, but at the same time, it simply has no edge. Of course, the universe is not even remotely a planet, but we can imagine it, let's say, as a hypersphere. It consists of points in four-dimensional space. This will be as close as possible to what we've described. So, in this scenario, if we send a satellite deep into the universe, sooner or later, it will come back to us. Why can this happen? As usual, it's all about gravity. It bends time and space. The greater the concentration of massive objects in an area, the stronger the curvature. All this leads to the universe bending so much that it connects with itself, forming a hypersphere. If this theory is correct, it doesn't mean we have fewer questions. For example, how can we grasp the universe's vastness? Initially, apart from this theory, scientists tried to find the horizon of the universe, which would prove its sphericity. However, this was not successful. But if we consider the hypersphere theory, it would seem to us that we live in a flat universe because its size would have to be enormous. By the way, speaking of size, if we try to estimate its size, it turns out that a universe of this shape must be at least 1,000 times larger than the observable part. We don't have exact calculations yet. In fact, the universe could even be billions of times larger than the part we can see. The theory with the hypersphere isn't the end of it. There are even stranger and in some ways rather comical versions. What would you say if I told you that our universe is actually a bagel? Yes, you heard that right. What if the shape of the universe is more like a three-dimensional ring? In this case, everything would be just like with a hypersphere. We would end up back at the point where we started our journey. Of course, there are some nuances here that might seem pretty strange to you. If the universe takes the shape of a kind of hyperbagel, then because of its specific structure, strange phenomena can occur. For example, if two satellites start their journey from the same point at the same constant speed, one of them will return to the starting point before the other. Or let's say a so-called mirror effect can occur in space, where we can see the same object in two places at the same time. In this way, we can observe a comet that is just forming, and by literally turning our head, we can already see it crashing into some planet. That's the kind of games light plays. Given such a strange and unnatural structure, such a universe would be the smallest compared to all other possible options. Its size would only be several times larger than the size of the observable part of the universe. However, it should be noted that such conclusions are weakly supported by any arguments, so scientists could be completely wrong about the size. So basically, we've covered the options for a finite universe. But what about the version where the universe is actually infinite? In fact, most scientists assume this option by default, since it is described in the cosmological model. This helps us understand what processes are happening in the observable part of the universe, and how we imagine an infinite universe. This is a space where you can travel forever without even changing course, but still constantly encounter new objects. That's hard for us to understand. Could the universe in that case have existed for eternity? Or was its origin based on that very nothingness? Here we can rely on evidence that at some point the Big Bang did happen in the universe. That means it has a beginning. And here it's worth noting an interesting point. We know that the universe is constantly expanding. However, if it was infinite from the start, how can expansion even happen? Here we can only say that as a result of expansion, the distance between galaxies and their clusters increases. So essentially, even an infinite structure can increase in size. That's the kind of paradox we end up with. It's very hard to understand and accept. However, that's the beauty of the universe. It's mysterious, full of oddities, and that makes us want to explore it even more. The paradox of an infinite universe makes us think about the nature of the cosmos and what place we occupy in it. The concept of an infinite universe makes us question our perception of the very idea itself. We even begin to doubt our mind's ability to handle such abstract concepts. As a result, we may come to very contradictory conclusions, the essence of which is very difficult to understand and accept. Do you enjoy watching ocean waves steadily roll onto the shoreline and watching incredible sunsets? When the orange sun sinks into the turquoise depths of the water, the vast ocean is one of the most beautiful landscapes on Earth, but it's strange to think that oceans exist only on Earth. Do you remember Miller's planet in the movie Interstellar? And the giant mountains that the crew saw on the horizon? Later, those mountains turned out to be enormous tidal waves, far larger than any tsunami on Earth. Undoubtedly, the film belongs to the science fiction genre, but such worlds do exist in the universe, and they are called Hycean planets. The strange name is actually quite understandable. It comes from the words hydrogen and ocean. These hypothetical water worlds could be habitable, which is why the James Webb Telescope is actively searching for such exoplanets right now. The device is designed to find signs of biosignatures on their surfaces, meaning any evidence of life or its consequences. This means that if life exists or once existed on a Hycean planet, James Webb will definitely find at least some evidence of it. What are these amazing, unexplored, mysterious worlds like? And are there any candidates for the title of Hycean? Let's start by answering the second question. Yes, there are. And that is the planet K2-18b. It is located 124 light years from Earth, and its parent star is the red dwarf K2-18. The planet completes a full orbit around its star in a record time, just 33 Earth days. Most likely, it is a super-Earth, meaning the mass of this celestial body is much greater than that of Earth. The planet was discovered in 2015, and since then, it has been studied by several telescopes, including Hubble, our famous namesake, and Kepler. It was they who discovered an excessive amount of water vapor in the atmosphere. That's where the assumptions came from that we're looking at a classic Hycean, and in 2023, James Webb also took a closer look at the planet K218b, and what did he discover? He found traces of dimethyl sulfide, a substance that on Earth is produced exclusively by living organisms. Of course, this doesn't mean we need to start packing our swimsuits into our suitcases just yet. If there is water on the planet, it could very well be in a boiling state. And over time, other facts may emerge that would prevent humanity from emigrating there. However, it cannot be denied that K218b is located in the habitable zone of its star, and that says a lot. Have similar Hycean planets been discovered before? Yes, they have. These are XO 1b WASP, 12b, 17b, and 19b, as well as HD 209, 458b. However, this is the first planet that is presumed to have water on its surface and is located precisely in the habitable zone of its parent star. Let me repeat, for Earthlings, this information is of purely scientific interest because, just like in the movie Interstellar, even if there is an ocean on this planet, it is likely to be continuous, without the slightest sign of land. And the characteristics of this body of water may be completely different from our rosy expectations. In 2028, the Aerial Telescope will launch to analyze exoplanet atmospheres. Then scientists expect to learn much more about Hygeans. And now let's try to answer the first question asked at the beginning of the video. What exactly are Hygean planets if we briefly model their conditions in simple terms for the average person? Let's begin with the scale and depth of global waters. Earth's oceans average a maximum depth of about 4 km. This doesn't include the Mariana Trench, but that's an exception. But Hycean worlds are even more impressive. Their depths can reach up to 100 or even 1,000 kilometers. It's hard to imagine a bathyscaphe or a submarine aiming to reach the bottom of such a body of water. Most likely, Cameron would never have lived to see the dive. What else besides the watery abyss can be added to the characteristics of Hygeans? Most likely, they have a very dense atmosphere made up of hydrogen vapors, which excellently retains heat. Its pressure must be high enough for liquid water to remain on the planet's surface. As for the temperature of the bodies of water at their extremes, the following can be said. They can be either extremely low or excessively high. Just imagine an ocean where boiling water is bubbling at an atmospheric temperature of 200 degrees Celsius. That's, for a moment, twice the boiling point. So why don't such oceans boil away? Remember what we mentioned a little earlier, extreme atmospheric pressure. It's exactly what keeps bodies of water from evaporating. In general, the conditions described are very similar to those on Venus, meaning they're absolutely unfit for life. But we shouldn't jump to conclusions because life could very well form inside the ocean. How are these planets worse than Jupiter's moon Europa? There's nothing preventing us from assuming life exists in its subsurface ocean. Due to the greenhouse effect, the planet Gikea won't necessarily be extremely hot. It's not that simple. For example, if a celestial body is tidally locked to its star, the far side of the celestial body can be quite cool enough for some forms of life to develop. Speaking of coolness, under the immense pressure of a water layer thousands of kilometers deep, a completely new form of ice can form, not the kind we're all used to. Let's take a brief scientific excursion. Atmospheric ice that forms on the Earth's surface is far from the limit of diversity for such substances. For example, if you cool water at a rate of 1,000,000 kelvins per second, you get glassy water, a completely exotic substance, unimaginable for the human mind. Ice can be cooled under enormous pressure, turned into diamond dust, or compressed at high temperatures. It is believed that such super strong substances cover the lifeless deserts of Neptune, Pluto, Charon, and Titan. Ice 5, with the most complex structure of all possible forms of this substance, also fits into this paradigm. To obtain it, water must be cooled under special conditions, minus 20 degrees Celsius and a pressure of 500 megapascals. This type of ice melts only at 50 degrees Celsius, no less. Why are we mentioning this? Many scientists believe that on Hycean planets, or rather at the bottom of these bodies of water, such blocks of ice may be compressed. The whole ocean might be made of that glassy water. Amazing discoveries await us ahead. However, let's get back to modeling the conditions on Hycean planets. What if such a celestial body is deprived of light from its host star? No problem. A hot core and dense atmosphere will do the trick. Thanks to them, there could be enough heat in the ocean for life to emerge. Remarkably, astrophysicists are almost certain, based on the data, that Hycean planets are the overwhelming majority in the universe, even more than super-Earths or gas giants. An unexpected conclusion, isn't it? However, we shouldn't paint especially rosy prospects. If there is life on such planets, it is most likely to be represented by microorganisms, or, in the extreme case, by some grotesque creatures crawling along the bottom of giant oceans or awkwardly swimming in their depths. In any case, for now, this is just a hypothesis. What if the rumors about the habitability of Hycean planets are greatly exaggerated? Let's think logically. What conditions are necessary for life to emerge? I mean, life that forms in a way similar to ours. 3 key conditions are needed: an energy source, such as a star or geothermal processes, nutrients, and liquid water. That's not a lot if you think about it. As for the parent star, Hycean planets can only exist near red dwarfs. That's where most of them are found, since even yellow stars like our sun are too hot for them. The water would just boil off. Regardless of the atmosphere's density, there's another aspect that supports the habitability of global oceans. During the formation stage of such celestial bodies, they most likely experienced meteor bombardment, which means that many cosmic objects sank into their waters, enriching the liquid with metals and organic matter at the same time. This is very fortunate because the lithosphere on such planets is poorly developed. They don't have continents or even islands or mountain ranges from which the necessary trace elements could be extracted. In addition, the conditions in some of these global bodies of water can be too extreme, so only organisms similar to extremophiles would be able to survive in them. But again, these are preliminary conclusions. No one knows anything for sure. It's possible that Hycean worlds are completely sterile, and we're holding on to false hopes. Finally, it's time for some truly fantastic theories. To illustrate them, let's recall the novel Solaris by the Polish futurist Stanislaw Lem. The story is about a planet with a sentient ocean. This amazing body of water influenced the orbit of its planet, preventing it from colliding with other celestial bodies. It was also able to create intricate structures above the surface of the gelatinous substance it was filled with. What if at least one ocean planet is similar to the one imagined by Lem? If you recall the prophecy of Wells or other science fiction writers, it's not such nonsense after all. So we'll be looking for life inside the ocean, while the ocean itself turns out to be alive and intelligent. In this work, there was a prophetic phrase: "We are not looking for anyone except humans. We don't need other worlds. We need a mirror." That's exactly how we can describe all our research, which is tied to earthly ideas about the origin, formation, and development of life. But let's not fall into melancholy, because it's possible that we are on the verge of great discoveries, and Hycean planets may play a decisive role in the fate of humanity's future. And it doesn't matter what they're filled with: supercritical fluid, hot ice, or protoplasm. We still need to study them. Such experience will open up even more opportunities and knowledge about objects in the universe for Earth sciences. If you don't study physics, your whole life will be filled with wonders and surprises. And that's not a joke at all. Indeed, everything around us, from the apple that fell on Newton's head to the expansion of the universe, operates according to the fundamental laws of this relentless science. Life is unpredictable, and what you strongly believe often proves to be an illusion over time. For example, is the fifth force of nature a myth or reality? Everyone who has ever opened a physics textbook knows that there are 4 such forces. So where did the 5th one come from? We got curious too, and we dug a little deeper. Is it hard to look for a black cat in a dark room, especially if it's not there? This question, asked by old Confucius, is considered rhetorical. It's used when trying to prove something unprovable or obviously false. Can this aphorism be connected to the search for the 5th one? Does it exist, and if so, what exactly does it represent? There is still no reasonable answer to any of these questions. So what is the 5th force of the universe? And why are scientists searching for it so eagerly? The thing is, in recent years, as the number of discoveries has increased, the standard model, which is the foundation of all known physics, is literally bursting at the seams. Evidence of something completely different, not fitting the usual laws, keeps appearing. For those unfamiliar with the theoretical basis of modern physics, let me briefly remind you what it's based on. In particle physics, there are 4 fundamental forces: gravity, the phenomenon of electromagnetism, as well as the strong and weak nuclear interactions. It is these forces that move all objects and particles in the universe, making a basketball, after passing through the hoop, fall to the earth. And the reason we haven't fallen apart into atoms is also thanks to them. But relatively recently, this unshakable foundation began to crumble. Why? The reason is the sudden discoveries that don't fit at all into the aforementioned standard model. The 2 worst enemies of this physical foundation are the hypothetical dark matter and dark energy. On examples, here you go. Scientists have been analyzing the behavior of galaxies for a long time, especially their rotation speed. And as a result, they discovered that there is something wrong with the total mass of the universe. A huge part of it is made up of an unknown substance. This form of matter was called dark matter. Astrophysicists didn't stop there, and as a result of further research, they discovered that the universe is not just expanding, but is actually accelerating significantly during the process. But for this, an incredible amount of energy is needed. The question is, where does the universe get it from? Scientists ended up concluding that some undetectable form of energy exists, which they called dark by analogy with matter. These are linked to the so-called 5th force, which supposedly explains inconsistencies between recent discoveries and modern physics laws. Neither dark matter nor dark energy can be observed directly. Their forms, characteristics, and composition are also currently unknown. We're searching for a non-existent black cat in complete darkness. Let's mention one important nuance. Each interaction in the standard model has its own subatomic particles for transmitting information: gluons, bosons, photons, and the yet unproven gravitons. Therefore, dark matter and dark energy should also have similar particles. In the first case, scientists propose WIMPs for this role, but right now this information is not essential. Another question: have physicists found any evidence of a 5th force that controls dark matter and energy, or a corresponding subatomic particle? You might be surprised, but yes. During the MUONG-2 experiment, which was conducted by scientists at the Fermi laboratory located in the small town of Batavia near Chicago, a major breakthrough was announced. The experimenters claimed that they had discovered a 5th force of nature, or a subatomic particle previously unknown to science. What was the experiment about? By analogy with the Large Hadron Collider, a particle called a muon was accelerated around a 14-meter ring while being subjected to a powerful magnetic field. The oscillations of the muon as a result were much more significant than expected, which led physicists to conclude that there is an unknown force. It was this force that was attributed to the unnatural oscillations of the muon. The statistical error for this experiment is quite large, so not everyone accepted its results. However, something was still affecting the muon, which means it could also influence everything else. The results of this experiment will be processed at least until the end of 2025, and only then will a final verdict be reached. This is not the only experiment that has been conducted in this way. Particle races were also organized at the Large Hadron Collider, and the conclusions were similar. The fifth force exists. If that's the case, then with one strike you can kill not just two, but hundreds of birds with one stone. After discovering the fifth force, astronomers can solve many unresolved questions and mysteries. Moreover, it's possible that dark energy doesn't exist at all, and instead it's that very fifth force that's accelerating the expansion of the universe to unimaginable scales. Let's look at it from another angle. Let's suppose the standard model will be supplemented with a new force. What exactly will change in our everyday life? Absolutely nothing, but on the scale of the macrocosm, quite a lot. First of all, we'll have to double the age of our universe. It'll become about 27 billion years. So what? Even now, the math is very different from what the James Webb Telescope and other devices are sending back to Earth. Secondly, when we put all the pieces of the puzzle together and find that cherished fifth element, quantum mechanics and the theory of relativity will finally get along, filling in all the gaps, inaccuracies, and contradictions. That's why scientists are actively seeking anomalies in experiments, hoping to find discrepancies between practice and theory that would prove an additional force of nature exists. Astrophysicists also claim that the fifth force could be comparable in strength to gravity, which means it may be significantly weaker than the strong and weak interactions. At what distances might the hypothetical fifth force effects appear? It is believed that it would act from millimeter scales up to the scale of the universe. It's worth mentioning the particle that acts as the carrier of the fifth force. What could it be like? Astrophysicists already have an approximate answer. It's the X-17 particle. Where does such a strange name come from? It's based on the mass of this boson, measured in electron volts. Again, its existence hasn't been proven experimentally. But physicists from Hungary in 2015 proposed this particle as the cause of certain anomalies that regularly appear during specific experiments. In short, throughout their experiments, instead of the number of electron-positron pairs decreasing during the bombardment of a lithium-7 target with protons, their number, on the contrary, increased many times over. The experimenters concluded that a particle unknown to science so far was involved in the process. That's why the result was strange and unpredictable. By the way, during the experiment, astrophysicists were trying to find dark photons, which are also hypothetical elementary particles that are believed to make up dark matter. But what they found is what they found. Moreover, Hungarian specialists repeated the experiment multiple times with other isotopes, and the result remained the same. Therefore, there can be no talk of coincidence. These experiments drew interest from University of California scientists who eventually reached the same conclusions. It is likely the particle carrying the fifth force has been found. Of course, the theory is also subject to criticism. Not everyone believes that a new particle could suddenly be discovered in a relatively well-studied range. This makes it clear that Hungarian scientists, unlike British ones, aren't to be trusted. Just kidding. Moreover, Andrei Rostovtsev, a researcher at the Institute for Information Transmission Problems, ironically recalled the story of the famous oscillation project with emulsion tracking apparatus experiment, which supposedly resulted in the discovery of neutrinos traveling at superluminal speeds. Upon closer inspection, a cable in the laboratory was simply connected incorrectly. Human factor can't change it. In addition to the X-17 particle, candidates for carriers of the fifth force also include the Z boson or a leptoquark. One way or another, humanity is most likely on the verge of discovering new physics or physics beyond the standard model. Theoretically, it has long been developed to explain the still unexplained things that telescopes send us, which do not fit into any of the existing physical models. What problems is the new physics supposed to solve? Of course, including the fifth force in it. Unfortunately, the standard model is unable to explain many things. The process of gravity, the fact that neutrinos have mass, they were previously considered massless particles, as well as the strange behavior of the muon and the asymmetry of matter. All of this could be explained by physics beyond the standard model, but even that is not the ultimate goal. As a result of numerous studies and experiments, scientists strive to form a theory of everything, a unified physical and mathematical conglomerate that explains all phenomena in the universe based on fundamental interactions, that is, forces. But apparently we still have a long way to go before we can form this universal law. So what awaits humanity next? Earth is like a car racing at breakneck speed through the darkness of times and spaces, but the driver's visibility is constantly limited. Blind spots keep appearing next to our stone bolide. Blind spots are anomalies that can't be explained from the perspective of the standard model. That's why physicists, like religious fanatics waiting for the coming of the Messiah, are hoping for the saving fifth force to appear and put everything in its place. And while that hasn't happened yet, we keep going about our daily lives. We're lucky. We live in a time when the science of space is advancing by leaps and bounds. We've learned a lot about distant galaxies thanks to high-tech telescopes and research probes. We've received countless images of such a diverse, such an amazing universe. It all looks like scenes from a science fiction movie, where space is a cozy and understandable place. However, not all of the universe is like that. There are planets that are completely plunged into darkness, and there are worlds whose conditions would remind us of the hell described in Christian scriptures. Sometimes we encounter planets where absolutely everything is strange, and today we'll talk about exactly those. What are they like, and why can we consider them anomalous? Usually among the vast number of worlds, we pay attention either to especially dangerous planets or to those where life could potentially arise. And we talk about these two categories quite often. Even on our channel, we've made a lot of videos about such planets. However, now we will focus on another category that attracts the attention of scientists, namely anomalous planets. On them, processes occur differently than they should. Such planets make us wonder whether the basic laws of astrophysics are correct, and not only those. Let's start with the yellow dwarf, which is located in the HD 80606 system. In many ways, it is similar to our Sun. Orbiting this star is the planet HD 80606b, which has a rather unstable climate. This object moves to the edge of the system at full speed, chasing after its parent star. The planet is classified as a gas giant. Its mass is 4 times greater than Jupiter's. Interestingly, if the planet has any moons, their temperature could be similar to that of Earth. However, conditions on the exoplanet are unstable because it is quickly approaching its star. The distance between them decreases by a factor of 30 in just 55 days. The temperature changes are truly astonishing. If you take the lowest points on the orbit, the surface temperature can double in just 6 hours. Such temperature fluctuations cause extremely powerful hurricanes. Their speed can reach up to 5 kilometers per second. You wouldn't be able to escape from something like that. However, the cataclysms don't end there. The exoplanet is shaken by shock waves that occur due to the rapid expansion of the atmosphere. Now let's talk about a system that's located 434 light years away from our Earth. There's an interesting planet here that we call Super Saturn, or J1407b. Its star is also quite similar to the Sun in many ways. Super Saturn itself is a bit more massive than its namesake in the solar system, and even more massive than Jupiter. Why was the planet called Super Saturn? This is because it has a ring system that's about 37 times larger, with a total mass greater than our planet. However, this ring system is not so straightforward. By itself, it's very unstable. Some parts of it break off and move farther away from the planet, while others, on the contrary, fall onto its surface. Helium and hydrogen dominate the planet's atmosphere. Scientists believe that Super Saturn is still in the process of forming. Its approximate age is about 16 million years. Inside the planet, there is a massive core made of metals. It is quite likely that Super Saturn has a massive moon that can push foreign objects out of its orbit, thus creating a gap in the ring system. In fact, there could be many such moons in a system like this. Considering all factors, including tidal forces and stellar light, one can conclude the temperature conditions there could be comfortable. The sky from the surface of such a moon could be very beautiful. Because of the strong glow, the night wouldn't be so dark, and above us we would see long bands of light. However, things can't be that good here. Since the objects are relatively close to each other, they are influenced by each other's tidal forces. If there is an ocean on the satellite, powerful waves will regularly occur, covering vast areas. And how could we forget volcanic eruptions? We move to the year 2009. In a separate region of the Kepler 413 system, an unknown celestial body appeared between our planet and the distant star, as if blocking it. At first, nothing seemed unusual about it. Most likely, this was the movement of an exoplanet. For scientists, this meant the discovery of a new cosmic object. However, things turned out to be not so simple. The scientists waited 180 days, but the movement never happened. On the bright side, during this time, it became possible to determine the parameters of the exoplanet. It is classified as a giant. Its radius is 40% larger than Jupiter's, and its mass is 25 times greater than Earth's. The exoplanet was called Kepler 413b. So what happened to it? After the expected transit did not occur, the object simply disappeared. The sensors on our instruments just couldn't detect it. At first, scientists assumed that the dust cloud near the star might be what the exoplanet left behind. However, what happened next was shocking. After 800 days, the exoplanet was back in the same place. After a while, it disappeared again just as unexpectedly as before. The exoplanet's strange behavior was unexplained for a long time, but eventually the reason became clear. It's all about the orbit of Kepler 413b. It has its own peculiarities. The exoplanet is very close to a binary star system. Gravitational forces constantly affect Kepler 413b, which in turn influences its orbit. As a result, the trajectory shifts too much. When the shift reaches its maximum, the exoplanet simply disappears from our field of view. The exoplanet's orbit shifts by about 2.5 degrees in both directions every 11 years. With such drastic changes, it's logical to assume the exoplanet's climate is very unstable. Of course, it was impossible to avoid drastic temperature changes. The fact is, the area that receives the most light from the star constantly shifts toward the poles and back. Most likely because of this, enormous forces arise on the surface of the exoplanet. We definitely haven't encountered anything like that, even on Jupiter. If hurricanes collide with each other, atmospheric outbursts occur that break out into space, overcoming gravity. Such outbursts can remain outside the exoplanet's atmosphere for a while, but then gravitational forces eventually take over and pull them back in. Yes, people definitely wouldn't survive there. Now we're approaching the system. Kepler 36 is 1,530 light years away from our planet. In the center, there's a star whose mass is almost the same as the Sun's. However, the Sun's radius is 62% smaller than the radius of this star. This star is surrounded by two objects, a small copy of Neptune with high temperatures and a super-Earth with a rocky surface. Every 97 days, these two planets come as close as possible to each other, almost 2 million kilometers apart. By cosmic standards, that's a tiny distance. Of course, the immense gravitational forces of both planets lead to catastrophic changes. This is especially noticeable on the super-Earth, called Kepler 36b, where crustal fractures and strong earthquakes occur frequently. Of course, there are also powerful volcanoes. They erupt huge amounts of lava, which form scorching lakes and oceans. The temperature on Kepler 36b is estimated to be around 700 degrees Celsius. The planet's radius is 1.5 times Earth's, and its density is about 30% higher. Kepler 36b is likely composed of iron and other heavy metals. It may be a gas giant that has lost its atmospheric envelope. So Kepler 36b can be classified as a hypothetical class of chthonic planets. Now let's talk about the second planet, which has been named Kepler 36c. Since the object is very close to its star, just like with the super-Earth, the temperatures there are high, about 655 degrees Celsius. The radius of Kepler 36c is almost 4 times that of Earth. The dense atmospheric layer is likely made of helium, hydrogen, and nitrogen. Such a planetary system can give rise to many destructive phenomena. Of course, the gravity of both planets changes their orbits. All processes are disrupted, making it difficult for us to predict how the system will develop further. Scientists believe that sooner or later the two planets will collide with each other, and as they break apart, will leave behind only a multitude of fragments. This will disrupt the order within the system even more, if there ever was any order to begin with. In the world of cosmic anomalies, every planet, every star is like a page from a science fiction novel. Beneath their seemingly ordinary surface lies an unexplored depth that expands our understanding of the universe. These anomalies seem to challenge our ideas about the laws of nature, enticing us to explore not only the outer boundaries of space, but also the limits of our own understanding. Do they lead us to new discoveries, or do they merely highlight the incompleteness of our knowledge? Have you ever wondered if we could change so much that our relatives would stop being related to us at all? For example, take Scott Kelly. He had an identical twin brother, Mark. Yes, he had. Because after many years, it turned out that their DNA no longer matched. Sounds grim, frightening, but what if we told you that space was to blame for all of this? Are Mark and Scott really twins? However, Scott became a record-breaking astronaut who spent 340 days and 8 hours in space. This was a very important experiment because it allowed scientists to observe how the human body changes in such conditions. And in the case of Scott Kelly, his genetic code changed significantly, although it should be said that people react differently to such conditions. We still don't know all the possible outcomes. And today we'll talk about the invisible but powerful influence of space. What if we look at its anomalies? What consequences could there be for us? To begin with, we'll discuss in more detail the experiment that was conducted on Scott Kelly. Before his flight into space, he was thoroughly examined. To accurately observe all the changes in Scott's body, his DNA was compared with the DNA of his brother Mark. As expected, they turned out to be identical, since the men were identical twins. The scientists expected significant changes in Scott's body after the experiment was completed. However, they were truly surprised by the nature of those changes. As a result, first, the gut microbiota became completely different, and the bones started to form a bit differently as well. Second, the telomeres, which are found in the chromosomes of blood cells, became longer. Third and most interesting, Scott became taller than his twin, even though before the experiment their height was the same. Most likely this was the body's reaction to a lack of oxygen and reduced gravity. If we consider such transformations as the body's reaction to stress, it makes sense to assume that over time all indicators should return to normal. Scientists continued to observe Scott, and indeed after some time his gut microbiome, telomere length, and even his height returned to their previous states. Well, space is not only beautiful but also frightening. This whole story is reminiscent of the plot of a science fiction horror movie like Event Horizon, where people who looked beyond the boundaries of known space became real monsters. But let's set our fantasies aside. You probably haven't thought about how astronauts cope with missions into outer space. Disruption of the nervous system, deformation of the eyeballs. This is just the tip of the iceberg. Space is scary, not just for its unseen destructive power, but also its emptiness. Yes, it seems to us that there are galaxies and clusters of stars at every step in the universe, but that's not the case. If we rely only on mathematical calculations, then let's say the amount of all matter in space is 0 point followed by 20 zeros and then 42 at the end. This tells us that most likely at a random point in the universe we won't see anything around us. We will be surrounded only by emptiness. And even if we find ourselves near the dark nebula, Bernard 68, we still won't see anything. Although there are many bright stars there, it's all because the cloud reflects the light coming from it back. For a powerful telescope, this might not be a problem, but for the human eye, it's a completely different story. Let's return to the question of matter. We've already realized that its share in space isn't actually that big, even though images of the universe make it seem otherwise. That the filaments of matter are everywhere, but even the 20% of matter that exists in the entire universe has a very low density. That's another reason space is very different from how it appears in photos. That's quite unusual to hear, but if we gather all the matter together and make a cube out of it, the length of its side would be several times smaller than the distance from the center of the Milky Way to our sun. And keep in mind that this literally includes everything, including galactic clusters, against which a galaxy looks like just a grain of sand. We Earthlings are lucky. At least at night, when the sky is clear, we can observe the stars. But how do worlds that lack this opportunity live? More precisely, let's imagine that somewhere far away there's a civilization living on a planet surrounded by impenetrable emptiness. How would this hypothetical civilization develop then? Would they even develop such a field as space exploration? Or would they think that there's nothing beyond their world? If aliens really existed and lived in such a world, we could only feel sorry for them. After all, they wouldn't be able to learn about the existence of many strange phenomena. For example, about the black cloud called APM 08270. This plus 5255 mass, it's 20 times bigger than the sun, and it emits millions of times more energy. This fact is already astonishing. However, that's not all. A cloud of water vapor has formed around the black hole. Yes, that's right, you heard correctly. And the amount of water there is 1 trillion times more than on Earth. Scientists have not yet figured out exactly how such a strange structure formed. Once, our probes spotted a black giant planet. This is the gas giant TRES 2b, and it is remarkable because it absorbs 99% of the light from its star. The surface temperature reaches nearly 1,000 degrees Celsius. You can also notice a reddish glow around the planet. This happens precisely because of the high temperatures. TRES 2b seems ideal for scientific research and sci-fi movies. In fact, when looking for something sinister, we don't even have to go far. There are plenty of interesting phenomena right here in our solar system. Here is a photo taken in 2014 by National Aeronautics and Space Administration is Solar Dynamics Observatory. Yes, this is our sun. However, in this image, it looks like a Halloween pumpkin. It looks a bit scary, although in reality it's just activity on the surface of the sun. A completely normal phenomenon. But if you look at Mars, its features give rise to conspiracy theories. In 2016, Curiosity sent a series of images of the planet's surface. And then, particularly observant people noticed a spoon and a fossilized fish. So does this mean that life once developed on Mars, or that someone has been to the red planet? Someone other than us? Sounds fantastic, but it's just the shape of the rocks. Here, everything is just too prosaic. You can not only see space, you can also hear it. Yes, there's a vacuum out there, so all that's left in our ears is ringing silence. However, National Aeronautics and Space Administration converted radio emissions into sound waves. So, we got the opportunity to hear our solar system. Here you have the sound of Titan, Saturn, Jupiter, the Sun, and more. Listen. Space is not just a sky filled with stars. It's a tremendous force that makes a person play by its rules, full of inexplicable phenomena. You don't joke around with space. There is so much we don't know about it. And as they say, the unknown can be very dangerous. Voyager 1. We've already talked about this amazing spacecraft more than once on this channel. For many years, it has held the title of the most distant man-made object from Earth in space. Right now, Voyager 1 is 24 billion kilometers away from our planet. The spacecraft launched on September 5, 1977. Naturally, not everything went smoothly during its mission. Voyager 1 had problems, and for the past few months, there had been no news from the spacecraft. It was obvious that some kind of malfunction had occurred. Considering Voyager's rather advanced age, such a turn of events is not surprising. And after a long silence, the spacecraft finally sent us a signal. How did this happen? What was the nature of the malfunction? And has the problem really been completely fixed? National Aeronautics and Space Administration scientists had been working hard to fix the spacecraft's issues, but this brought many difficulties. First of all, since Voyager is already quite old, the technologies used to build it have long been outdated, and the situation hasn't changed much even after several system updates. To give you an idea of the scale of the problem, Voyager's systems are capable of processing 8,000 commands, while our smartphones can handle 100 billion commands per second. Secondly, another problem arises from all this. The team that worked on Voyager in the early stages has long since moved on. Modern scientists had to work really hard, studying archival documents. Figuring out how the spacecraft's systems function was not an easy task. To understand what the malfunction is all about, we'll tell you a bit about the Voyager computers themselves. They operate in the binary number system. It transmits information using 2 bits, 0 and 1, which combine in various ways to send data like images or sound signals. Just think about it. So much diverse data reaches us thanks to these 2 numbers. It should be clarified that before being sent to Earth, the data is converted into a modulating carrier signal that can carry information. The data also reaches Earth thanks to a system of radio antennas located in different parts of our planet. This system is known as Deep Space Network, or the Deep Space Network. It is necessary to ensure uninterrupted reception of information from all spacecraft and to prevent problems that may arise due to the rotation of the planet. There are 3 computers on board the spacecraft, and the malfunction happened with one of them. We're discussing the Flight Data System computer in the Flight Data System. It's especially important for us because it collects data about the observed area of space and about the operation of the spacecraft itself. It is the Flight Data System that transmits this information to the Telemetry Modulation Unit, which in turn processes it and sends it to Earth. And the last time, the Telemetry Modulation System sent us a rather strange signal, which was just an unreadable mass of numbers. The scientists realized that the Flight Data System was malfunctioning and distorting the data. Such situations often happen with spacecraft, and then they simply restart the system using the well-known method of turning it off and on again, and in most cases, that helped. That's how they once fixed malfunctions with the Hubble telescope and with Voyager 2 back in 2010. The same procedure was done with Voyager 1. However, after the reboot, the Flight Data System still didn't start working correctly. The scientists had to review vast information about the Voyager systems and their development to find a solution. Then a hypothesis emerged that the problem was in the microchip. To find out if this was really the case, the scientists launched the so-called POK command, which allows direct interaction with the system's hardware by changing the necessary parameters. Using the POKE command, the process of information processing was launched in a different sequence inside the Flight Data System. When the scientists received a new batch of data, they compared it with the data that had been obtained before the malfunction occurred. It was obvious that the formatting was now happening differently than before. And then it turned out that one of the microchips had stopped working. This caused damage to about 3% of the Flight Data System's memory, which included important program code. This serious malfunction couldn't be fixed by restarting, and finding a solution was difficult since replacing the microchip was impossible. Then the scientists thought about moving that important program code to another area of memory that wasn't damaged. However, it was impossible to implement because no compartment was large enough to fit it. The scientists took extreme measures, splitting the code into parts to move them to other cells while preserving functionality. This process took quite a lot of time so that the scientists could properly replace some components of the code. Separating the section responsible for the device's technical specifications was important. On April 18th, she was moved to another compartment. After that, Voyager was commanded to prepare the data for transmission to Earth again. Their scientists were eagerly waiting for them, as they were the answer to whether the problems had been fixed. On May 20, the big day arrived. Indeed, everything worked out, and now the scientists could monitor the condition of all Voyager's components. To celebrate this event, National Aeronautics and Space Administration posted on their page with the words, "Hello, it's me. That's not all. The malfunctions aren't fully fixed." The scientists still have a second part of the job ahead so that the Flight Data System can collect data from outer space and process it correctly. National Aeronautics and Space Administration is currently transferring codes to the undamaged Flight Data System memory sections. The information from Voyager 1 is very important to us because it is very far from our planet and can study phenomena such as cosmic rays, which we cannot investigate with other spacecraft. Despite the fact that Voyager 1 is moving farther and farther away from us, and we are facing more and more obstacles, the spacecraft continues its mission. Most likely, both Voyagers will run out of power after 2025. After that, they will travel alone through the vastness of the universe, having lost all contact with Earth. There is a chance that in 40,000 years, Voyager 1 will be near the star Gliese 445 in the constellation Camelopardalis. However, we on Earth will never know about it. Perhaps humanity will not even exist by then. Watching the two Voyagers, we often think about how much hard, painstaking work went into these spacecraft and how much effort was invested in their development. Both the scientists of the 70s and our contemporaries agree that the Voyagers have forever taken an important place in space science. What do you think? Will we ever receive more news from these spacecraft?